Hi, my name is Niiman Kesara. Today I want to explain to you about chemical bonds and how to draw Lewis structure. So what is a chemical bond? Chemical bond is a strong attractive force that exists between atoms in a substance. There are three types of chemical bonds: ionic bond, covalent bond, and dative covalent bonds. So the first one is ionic bond. The electrostatic static. So the first one is ionic bond. The electrostatic force of attraction between a positive ion, which is a cation, and negative ion, anion. So this is the example, Na plus Cl. So Na has one electron, so it transfer of electron. So it transfer to the Cl. So it makes sodium chloride. So the second one is covalent bond. Covalent compounds that contains only covalent bonds. So a covalent bond is a chemical bond in which two or more electrons are shared by two atoms. So atom 1 and atom B. Atom 1 is non-metal and atom B is non-metal or metal. So atom A and B is sharing of electrons, so it makes covalent molecule. So the last one is dative covalent bond. A coordinate bond, also called a dative covalent bond, is a covalent bond, a shared pair of electrons in which both electrons come from the same atom. So atom 1, electron donator, and atom 2 is electron acceptor. So atom A is pair of valence electrons available for bonding. So it makes a covalent molecule if sharing of valence electrons coming from A. So the next subtopic is drawing Lewis dot structure. So the Lewis structure is a simple two-dimensional representation of the position of electron pairs around a central atom of molecule. So valence electrons are distributed as bond pairs and lone pairs. So this is how you want to draw Lewis structure for CO2. So the first step is you should calculate the valence electron, and then the second step you should know how to do the central atom. So the third step you should draw like that, as you can see at the slide, and then the fourth you should know lone pairs and octet rule, and then the last step you should calculate again the total electrons, and then that is how you draw the correct geometry. So this is the table that you should remember.
My name is Muhammad Zaid Iskandar. I will be explaining about octet rules and its exception. Octet rule is a chemical principle stating that atoms tend to gain, lose, or share electrons to achieve a stable configuration with 8 electrons on their outer shell. An octet corresponds to an electron configuration ending with s2p6. Example, Mp10 equals to 1s2, 2s2, 2p6. Exceptions to the octet rule. It's an odd number of electrons, it's less than an octet, and it's more than 8 valence electrons. Odd number of electrons. Though relatively rare and usually quite unstable and reactive, they are ions and molecules with an odd number of electrons. In freeze condition, NO will form diamine to reduce N2O2. In this structure, the nitrogen is already an octet configuration. Less than an octet. Consider BF3, giving boron a field octet. Place a negative charge on the boron and a positive charge on fluorine. Boron is less electronegative compared to fluorine. As you can see, this would not be an accurate picture of the distribution of electrons in BF3. Therefore, structures that put a double bond are much less important. If filling the octet of the central atom results in a negative charge on the central atom and a positive charge on the more electronegative octet atom, then fill the octet of the central atom. More than 8 valence electrons happens for elements in the third period such as phosphorus, sulfur, and chlorine. Use availability or details to accommodate extra bonding electrons. The larger the central atom, the larger the number of atoms that can surround it. Next, we're going to talk about molecular shape. VSEPR is an abbreviation of valence shell electron pair repulsion theory. Most important factor in determining geometry is relative repulsion electron pairs. There are two types of pairs, no-lone pairs and with lone pairs. Molecules with no lone pair. AB2, beryllium chloride. The bond angle is 180 degrees. The molecular geometry is linear. Next, we got AB3, boron 3 fluoride. The bond angle is 120 degrees. The molecular geometry is trigonal planar. Next, we got AB4, methane. The bond angle is 109.5 degrees. The molecular geometry is tetrahedral. AB5, phosphorus pentachloride. They got two bond angles, 90 degrees and 120 degrees. The molecular geometry, trigonal bipyramidal. Next, AB6, sulfur hexafluoride. They got two same bond angle, 90 degrees. The molecular geometry is octahedral. Molecules with lone pair. They are more complicated. There are three types of repulsion: lone pair with bonding pair, lone pair with lone pair, and bonding pair with bonding pair. In this notation, A represents the central atom, B represents the surrounding atoms bonded to central atoms, E represents the lone pair of electron on central atom. X is the integer count of these atoms and Y is the integer count of these lone pairs. AB2E, sulfur dioxide. The bond angle is 119. The molecular geometry is red. The last one is AB4E, sulfur tetrafluoride. There are two bond angles, 173 degree and 102 degree. The molecular geometry is distorted tetrahedron or seesaw.
Assalamualaikum and hi, my name is Nur Arafah and I'm going to talk about formal charge and noble gas. Okay, formal charge is the charge assigned to the individual atom in the Lewis structure. It also determines the best Lewis structure. How do we want to calculate the formal charge is by number of valence electron we minus with the number of electrons that owned by an atom. The number of electrons owned by atom is determined by its number of bond and lone pair. All of each unshared electron, H, half of each shared electron. As we can see here, we have ammonia. For example, we have NH3. And then for H1, let's see the H1 first. H1, we know that H1 have electron, only one electron valence. Same with the other H2 and H3 also. So that's mean hydrogen, it only own one. So when we go to nitrogen, as we know, nitrogen is in group 15. So of course, it have 5 valence electron and also own 5 electron. But the formal charge for all of it is 0. Same goes to the next. For formal charge and Lewis structure, the best Lewis structure, the first one is smaller formal charge, either positive or negative. Second, a more negative formal charge is assigned to the most En atom. 3. Avoid charges like positive, positive, or negative and negative on adjacent atom. So let's talk about the resonance and formal charge. For example, we have nitrogen chloride has 3 possible resonance form. Choose the most possible structure. So let's see which A, B, or C is the best possible. So first step is determine formal charges. For A, B, and C, B and C have smaller formal charge, which is make them more important than form A. That is the rule 1. So and then C has a negative charge on oxygen, which is more electronegative element, contributes the most to the resonant hybrid. That is the second rule. So this is the example answer. 3 possible Lewis structure for nitrogen dioxide is we how we want to know which is the possible Lewis structure is we're gonna find formal charges, count non-bonding electron, and 1 electron for each bond. Then we subtract the electron count from the valence to get the formal charge, and then that is how we know the best Lewis structure. For this example, the best Lewis structure is the far right, which is the most right at the right, because it has all atoms for formal charges as close as possible to 0. So octet rule and its exception. For octet rule has state that atoms tend to gain or lose electron until they have 8 electron in their valence shell to form stable compound, which is to reach the octet number, which is 8. An octet corresponds to an electron configuration ending with S2P6, because if we combine or plus 6 plus 2, we're going to get 8. For example, 1s2, 2s2, and 2p6. We're going to take the sixth one plus with 2. So when we plus the number, we're going to get 8, which means the atom has reached the octet rule. For odd number of electron, we going to look at the picture. Though relatively rare and usually quite unstable and reactive, they are ions and molecules with an odd number of electrons. In phase condition, nitrogen oxide will form dimer to produce N2O2. In this structure, the nitrogen is already get an octet configuration, which is like nitrogen have 3, the other 3 electron, and then the oxygen have 4. Then we can see like the nitrogen get 4 after the transfer or share, it reached the octet rule. For less than an octet, we have, for example, boron trifluoride. Boron trifluoride giving boron a field octet places a negative charge on the boron and a charge on fluorine. Boron is less electronegative compared to fluorine. This would not be an accurate picture of the distribution of electron in boron trifluoride. Therefore, structures that put a double bond are much less important. If filling the octet of the central atom result in a negative charge on the central atom and positive charge on the more electronegative outer atom, don't fill the octet of the central atom. Which is, that means like we just put the electron at the outside center. Which is like we can see here, the fluorine, we put the electron around fluorine and not the boron. Okay. So for more than 8 valence electron, which is the expanded one, only applicable to element in third row or below, which is, that means period 3 and below than period 3. How? Use their empty orbital to accommodate additional electron, which means like we can say the larger the central atom is, the larger the number of atoms that can surround the central atom. I guess that's all from me.
My name is Nur Alimizulai Community Muhammad Fazdalis, and I will be explaining about dipoles, moment, and bond polarity, and also intermolecular and process. First, we must know about dipole moments and polar molecule. Dipole moment is the separation of electrical change in molecule caused by unequal distribution of electrons. And for polar molecule is a molecule that has an overall dipole moment due to unequal charge distribution. For example, fluorine has higher electronegativity than hydrogen. Electron then will attract to fluorine atom. The fluorine atom's high will become an electron-rich region with a partial negative charge. For hydrogen, it becomes an electron-poor region with a partial positive charge. This separation of charge will create dipole moment, therefore HF also classified as polar molecule. There is two types of polarity of the molecule. One is polar molecule and the other one is non-polar molecule. Polar molecule is diatomic molecule composed of different atoms have different moment, and for non-polar molecule is a diatomic molecule composed of atoms with the same element. Depends on the polarity of the bond, and it also depends on the shape of molecule. And here are some examples for polar and example for non-polar. So, what is the difference between multiple versus molecular dipole? Multiple is polarity in an individual bond, and for molecular dipole is overall dipole of the molecule. So, here's come the best part: intermolecular forces. There is two types of forces, which is intermolecular and intramolecular. So what is the difference? Intermolecular exists between the molecules and influence the physical properties of the substance. And it has hydrogen bond and anti-friction forces. It also be weaker. And for intramolecular, it exists within the molecule and influence the chemical properties of the substance. It also has ionic bond and covalent bond, and it is stronger. First, we have London dispersion forces, LDF. So what is the meaning of London dispersion forces? London dispersion forces is a temporary attraction caused temporary dipoles due to electron movement occurs in all molecules, mainly non-polar molecules. For example, H2, Cl2, and F2. And next we have ion dipole. Ion dipole exists between ion and polar molecule. It has strong interaction between ion and polar molecules. For example, Na and H2O. So next, we have dipole-dipole forces. Dipole-dipole forces is attraction between polar positive end of one polar molecule and the negative end of another polar molecule. For example, HCl, CH3, and also Cl. Hydrogen bond. Hydrogen bond is when H bond to NO or F. It has stronger bond walls. For example, H2O, NH3, and also HF.